Okay, so let's go through one last set of examples to show you what all of this stuff is that we're going to do, that we put it together. Okay, let's put together what we've just learned. Let's say we're interested in finding something like the sine of 330 degrees. What do we do? Well, we're going to use our reference angle. We're going to determine the sine of the function based on the quadrant, and then we're going to use these items to help us determine the value of the function. All right, so we just found the 330 degrees, right? We just looked at 330 degrees, and we determined that 330 degrees is in quadrant 4. Okay, so we are an angle in quadrant 4, which means the following items. Number one, that our angle, our reference angle, is equal to 30 degrees. Okay? Secondly, in quadrant 4, we know that sine is negative. Okay, so we should be getting a negative value. Finally, we know that the sine of the angle 30 degrees, our reference angle, would be equal to 1/2. So this is the actual value of the trigonometric function. So when we say sine of 330 degrees, we take the sine of our reference angle and add the correct sign, S-I-G-N, from the quadrant, and we're going to say, well, the sine of 330 degrees would be negative 1/2. That's our value. Okay, so let's try it with a different one. Let's try 660 degrees. What do we know about that? Well, that is definitely larger than our angle. So we're going to have to do a couple of little extra tasks right here. For one, we have to get our angle, our reference angle, right? So which means we're going to have to take our 660 degrees and find a coterminal angle less than 360 degrees. So let's subtract away 360 and see what we've got right here. We've got a 300-degree angle, right? So that's between 0 and 360. And by the way, I happen to know that's in quadrant 4. So I'm going to take 360 degrees minus 300 to get my reference angle. That's 60 degrees. So this is my reference angle. Since I'm in quadrant 4, I know that cosine is positive, and I know that the cosine of 60 degrees happens to be equal to positive 1/2, and so the cosine of 660 degrees is going to be positive because we're in quadrant 4, and 1/2 because our reference angle has a cosine of 1/2. And that's it. How about 4 pi over 3? Well, let's determine where 4 pi over 3 is. I think we already did that, right? No, not yet. Oh, yes, we did. 4 pi over 3 we determined was an angle in quadrant 3. Right? So we just did this in the past, 4 pi over 3. So cotangent of 4 pi over 3, we know we're in quadrant 3, which means that the tangent is going to be positive in quadrant 3, and that our reference angle, theta prime, was equal to 4 pi over 3 minus pi, which we determined before by subtraction to be equal to pi over 3. And furthermore, we know that the tangent of the angle pi over 3 is equal to square root of 3. Therefore, because we are in quadrant 3, the tangent of 4 pi over 3 is a positive value, and it's equal to the square root of 3. Okay, so finally, let's look at cosecant of 11 pi over 6. A little bit more challenging, but not so bad. 11 pi over 6. Well, 2 pi in terms of pi over 6 is 12 pi over 6. So this is just shy of that. As a matter of fact, I would wager that this is in quadrant 4. Right? Quadrant 4. So I know that sine is a negative in quadrant 4. Therefore, cosecant must also be negative in quadrant 4. And that my reference angle will be found by taking 2 pi minus 11 pi over 6. So I'm going to take 2 pi minus 11 pi over 6. That's 12 pi over 6 minus 11 pi over 6. Which gives me a reference angle of pi over 6. So what do I know about pi over 6? Well, the cosecant of the basic angle of pi over 6 we found to be equal to positive 2 over 1. And since we're in the fourth quadrant, we'll say that the cosecant of 11 pi over 6 is negative because of our fourth quadrant orientation, and 2 because that is the cosecant of our reference angle. So the cosecant of 11 pi over 6 is negative 2. All right, good luck on your homework. I'll see you in class.